Good morning, good afternoon, wherever you're tuning in from, and welcome to the latest edition of the Security Middle East Magazine webinar series. Today, this session is being hosted with the support of Icetana AI. Icetana have emerged as a world leader in self-learning security AI that integrates with existing VMS. They have over 40 deployments in 4 continents, spanning a wide range of industries. Icetana AI continues to spearhead the market and improve situational awareness and operational insights for its customers. We have a couple of expert speakers from Icetana today. Joining us from the Middle East region is their Regional Sales Director, Mohammed Sheikh, who brings over 20 years experience in security. He's been at the forefront of AI adoption in that time and has leveraged the technology to work with governments, property developers, and aviation to keep people safe. We're also joined by the company's CEO, Kevin Brown. Kevin is a leader in AI CCTV security with over 15 years of experience. His leadership at Icetana has driven advancements in autonomous security, helping organizations detect and respond to threats in real time by leveraging artificial intelligence. Now, the gents have got a really interesting presentation for you today, so I don't want to delay getting stuck into that. Just please be aware to our audience that if you do have any questions, you can use the chat function and the Q&A function at the bottom of your screens, and I'll be hosting a short session following the presentation where we can ask Mohammed and Kevin all of the questions that are on your lips today. So look, without further ado, Mohammed, I'd like to hand over to you for the presentation.
Great. Thank you very much, Ryan. It's such an amazing time to be actually here to present to all of you. And without further ado, here we go. The agenda for today is the evolution of CCTV monitoring, where I'll go into the background of how we came about to where we are today. And then Kev will take on and talk about the advancement of technology, how AI agents work, and the next. And finally, we'll end with our Q&A session, which will be hosted by Ryan. So without further ado, here we go. Let's talk about where we started. Traditionally, there was no automation. There was only manual monitoring, which required a lot of human operators, multiple screens, and which would lead to a lot of fatigue from the operators. In fact, the metrics is that after about 20 minutes of watching a single screen, 95% of screen activity was lost. It was a very reactive approach. That meant that they wouldn't identify, and even if they did identify, they may not be able to respond in time. It was limited scalability because they were limited by the capability of the operator and the screens that were on display. It was prone to high false positive rates, and operators were always overwhelmed. And it was extremely resource intensive because there were only so much human capital to work with the command and control center. Then came the partial automation phase. Now, here with the advent of detection, with motion detection, with the differences in pixels that were recorded, an operator was able to do about 50 cameras at a time, and he was able to, using CCTV, he was automatically recording. Now, this actually still had some drawbacks because operators were still stuck with predefined rules. There was limited flexibility that meant they could not distinguish between routine activity and real security threats. It was prone to really high false positive rates, such as think about shadows, think about lighting changes, or even environmental factors such as swaying of trees or leaves blowing. And it still required a lot of manual intervention from security teams. So just to give you an example of how it worked, IT teams had to be employed. They had to create these manual lines, these predefined rules. And the drawbacks was that it was extremely time consuming for IT departments to go scene by scene, especially when it came to large deployments. It was not plug and play. That means there was no adaptive AI solutions in place. And in terms of efficiency versus accuracy, it took a real toll on the operators. We then come to the next, which is where with partial automation using basic video analytics, the systems got a little bit smarter, which meant that an operator could handle up to about 250 cameras now, but it was still prone to high false positives. There was lack of explainability, so operators would always be confused about what triggered the alarm, why were they looking at the scene, and where does partial automation really help? So it still lacked intelligence. There was still a lot of unnecessary work for security teams, and real threats still had a chance to be missed. And there came us, where we are now with our AI-driven learning system. This is where we are currently. We moved beyond predictive and basic analytics to intelligent adaptive monitoring. Our AI user feedback helps operators to become smarter. They can see less of what is mundane, and they can teach the system on what they're actually looking for. This is where we roll out Icetana, because from 30 to 50 operators, we went off to about 500 cameras and beyond. There are some clear advantages to this. For instance, there is proactive monitoring. So now you only see unusual activities in real time, so that you can respond, or the operators can respond and prevent escalating situations. We have enhanced scalability. That means one operator can now manage hundreds, and in certain cases, even thousands of cameras using AI filtering. It reduced the fatigue. So only important events were seen by the operators, which improved their focus. And lower false positives were enhanced because of operational efficiency. And it reduced the cost. For instance, it was better for return on investment. It reduced the reliance of large operating teams down to 1 to 2 to 3 operators in most scenarios. And the best part was it was continuously learning from a dynamic environmental change. To exemplify how this works, so here is a situation where you have an escalator or travelator. The person on the right is actually using it in the correct way, but children being children, they're using it the wrong way. Very important for you to note is the system is self-learning. So it learns the traffic patterns. So people walking on the side of the escalators do not raise an alarm. It has clear key advantages to this, because now it saves your operations time, because there are no manual rules to create. It's plug and play. So it learns within the first 24 hours of implementation, and it continually learns and adapts from a dynamic environment. And all of this is in real time, so therefore it reduces the false positives. With the next is going to be our AI agents, and we are launching our watch and triage agents, and we're heading to north of 2,500 cameras per operator. I'm now going to hand it over to Kevin to discuss in more detail about AI agents and the next steps to autonomous CCTV security. So Kevin, over to you.
Thank you, Mo. Look, our product backbone is built on what we often refer to as guard power. So we talk about the number of cameras that each security operator can effectively manage. And what we're finding with new AI agent technology is that we are conservatively increasing the camera per operator from 500 to 2,500. Have this running in the lab at the moment, and we have the triage agent in particular that I'll speak to a little bit about what agents are and how we expect them to change the face of security, especially in CCTV. But at the moment, the triage agent in a security, in a SOC environment, what often happens is that the CCTV or the AI will find things that are interesting or unusual. They'll put them in front of the operators, and those operators will make a judgment call as to whether we need to call an ambulance, call the local police, call the SWAT team, or bring a bucket and mop to clean up a spillage on on aisle 9. So we've been running in the lab where we're choosing GPTs, or large multimodal large language models. So if you're not aware of this technology, you will be aware of OpenAI and ChatGPT. A lot of the models today are large language models, but some of them are multimodal. And what that means is that we can plug images, or in some cases videos, into AI agents, and those AI agents have the cognitive power to assess a situation. So to give you an example, the triage agent can ask for you can ask out, like at the moment, our triage agent broad questions like, is a person in danger? Is the property in danger? Or is there some, is work needing done? Does this need escalated? Now, the reason why this is interesting in security terms, and especially in autonomous security, is that critical part of the process when you have a security teams who are potentially managing thousands of cameras. Often, even with AI, the human users can miss particular events. So we use the triage agent to augment the human human assessment of the events that the other AI has found. And like most AI improvements, we currently focus on training the security team on how to manage AI. And the more experience the security team have in AI, then the better they are at managing these AI agents. So just as a rough analogy, we consider the AI agents to be AI staff who work for the security team. So the watch agent is a slightly different agent. The watch agent is an agent that looks for specific events across all the cameras. So you may have, historically, if you wanted to build up fire and smoke detector, you would have to build models to do that. And with the watch agent, you can simply write fire and smoke, and the AI will find it. This is emerging technology. It's expensive on compute. So as the models at the moment are large, which means that you need to use this technology sparingly. But combined with Icetana's suite of algorithms, we've got quite a compelling offering in terms of cost and compute. So this means that if you have specific things that you're looking for, person in a wheelchair, police turning up, someone holding a gun, someone holding a knife, you can simply describe this in text form, and the watch agent will search all the cameras in real time and find those events should they occur. In our move towards the holy grail of autonomous security, and autonomous security is very much like autonomous driving. No one at the moment, you can't currently read your book while you're in a Tesla. Like the autonomous driving has its limits. This is a frontier that's being pushed out with various technologies. It's the same with autonomous CCTV security. So we're pushing the limit towards full automation. We still need people to manage the AI agents, but just to give you an idea about what we think is coming around the corner, which will move our customers from 2,500 guard power, we will move this to an infinite number of cameras, which means that the AI agents can manage the lion's share of the CCTV process. So you can imagine we have watch agents that currently find specific events. With a watch agent, you can actually, if you were managing the security in a mall, you can actually upload the rules of the mall, and the watch agent will scan all the cameras and look for breaches. Like, for example, don't put a ladder in front of a window. For example, don't leave boxes in front of fire escapes. So you can simply upload the rules of the mall, and the watch agent will monitor all of the cameras to find breaches to these rules. The next step is the triage agent, and again, we have both of these technologies working in research and development. We expect to have them in production in the next month or two. So the triage agent monitors the events from the watch agent and from the rest of the self-learning AI, and it makes a judgment call based on the decisions that the security team define. So if there's someone in danger, phone an ambulance. If there's, if we need to get the police in, we get the police. But at the moment, our AI platform doesn't make the phone call. It will simply escalate it, put it in front of the security team, and they're the ones who make the actual phone call. However, we believe that the next frontier of autonomous security will include verification agents. And a verification agent at the moment, it would be a replacement for the person who currently looks at the triage agent and says, are we sure? Like, before we call an ambulance, let's just double check to make sure that this is a real event. So we've got these emerging technologies in the lab. And then the next thing that we expect to move towards full autonomous CCTV security is the resourcing agent. So at that time, if there is a spillage, the resourcing agent will understand where the cleaning crew are in the location, and it will get a message to the cleaning crew to say, hey, bring the cleaning material to this particular part. This resourcing agent we expect to be also understanding of where security teams are, how well resourced they are, in particular regions in the world, whether these security team members are armed, or whether we need to contact the medical team. So we expect this resourcing agent to do the thinking around where to escalate. And finally, the execution agent is, this is the equivalent of the person who gets on the phone. There are real strong technologies on the phone these days. So the execution agent could literally be an AI that picks up a phone, calls someone, and gets the message to them so that they get the message. The number of different channels that the execution agent can exist on is increasing. So look, it's an exciting time to be in AI. It's an exciting time to be in security. We're seeing things that are accelerating our autonomous security strength, emerging, often weekly. And so hopefully this gives you a good idea about where the industry has came from. What you see here is the growth in Icetana AI that we've witnessed over the last 15 years. And we expect even in the next 5 months that we will be accelerating at a rapid rate. Hopefully this so far has been useful. This will give you an idea about what the AI agents actually look like. So here you can simply write, someone has been injured, property has been damaged, and the spillage. And what I'll do after this is I'll actually show you what this looks like in the product. So let's have a look here. So here, what we have is when the results of when we ask our GPT, is anything dangerous happening? And what you're seeing just now is what the GPT actually has written. Just this may be a technical detail, but we can hot swap the GPT. Like we're more of a wrapper for large language models. We can use OpenAIs, we can use Google's, we can use open source. For some of it, we could use DeepSeek, but largely we require a multimodal model for the actual images themselves. So here, what you're seeing on the left is the GPT spots that there's a person standing on a small pillar, which could consider them dangerous. This gives you a real insight into the additional cognitive layer that these AI agents can add. We've came a long way from video analytics, where we simply pull images out, we simply pull objects out and count them. Our main AI platform pulls the objects out, builds individual models for each of the cameras based on time, direction, speed. We have a whole suite of machine learning algorithms and deep learning algorithms to get to this stage, but this acceleration in cognitive power opens up quite an opportunity. On the right, you can see that the GPT can see that there's someone carrying a knife. In Australia recently, there was an outbreak of knife crime. We dug into the technology for finding people carrying knives, but we used the GPT as a verification here. So the GPT can see the knife. It's actually quite difficult to see, but it also understood the context of the scene. So it could say it's likely a butcher or a store employee as they're standing behind a meat counter. And at this point, the agents would understand not to call the police because someone has a knife. It would understand the context. Look, this is the system in action. This is what you've just seen there. What you're seeing is the real live product. You can see the butcher up there, and you can see the notes that our AI built. Next one, please. Yeah, and here, so again, the GPT is searching all of the cameras, and again, we just asked it, is there something dangerous happening? And it could understand that this was actually a dangerous event. Look, we've put this in here just even though we have security professionals, this was one that stumped us because it says there's a person lying in the ground. That even our object detectors wouldn't find this, but if you look up the back, you can see that there is actually someone laying in the ground. So just having this additional agent verifying the safety of people and property increases the level of security across the board. Look, one of the other things that we're looking for, or that we think will come in the future. Mo, would you like to talk to this, or?
Absolutely, Kevin.
Thank you.
Thank you so much, Kev. Look, when it comes to feedback loops and when it comes to AI-driven feedback loops, not only the security team, but this has a lot of applications on multiple different verticals. I mean, let's take safe cities, for instance. Cities can start planning based on the feedback loop, based on what is the normal that they see that their city is. They can identify hotspots. They can track movement patterns. They can understand what the customer journey would look like and prevent bottlenecks and traffic jams. If we move inside into environments, let's say a mall environment, then the marketing team, not just the security, but the marketing team could benefit from feedback loops because they can understand what would be the trend analysis or the engagement patterns of their visitors. They can understand customer demographics or understand the footfall traffic, enhance their customer experience identify the hot zones that these malls experience, or property management, for instance, lease negotiations with retail tenants, or space allocation when it comes to events. The impact of intelligent AI-driven systems will benefit organizations and governments as an entity as a whole. Anything else I've forgotten, Kev?
Yeah, one of the things that we're seeing in the market is because our AI is self-learning, it takes 24 hours to learn the basics, and then after a week, it will be smarter still. So it will compare 3 o'clock on a Wednesday to 3 o'clock on the Wednesday. Often what we're doing to accelerate the context learning is that we will get a copy of the security reports for the last 3 months, and we can feed that into the GPT so that the system can be finely tuned to find more of the escalating events that the security team have reported in the past. So there's this overall, when I'm doing the other way, overall feedback loop where we can jam the knowledge into the AI, and it accelerates the learning when we put it on site. So we're having a lot of conversations with some quite sophisticated security teams who are open to this idea of accelerating the training so that they increase their security posture as soon as possible.
Great. I think I would like to leave with, I think a picture always paints 1,000 words. And I'd like to show what the current status of most command and control centers are, where you have a bank of screens, you have nothing but moving images, and you have a few operators trying to understand the scene and trying to watch out for something that could be of threat or a medical issue. Whereas what the future would look like with self-learning AI in place, where only events that really require the operator's attention would be displayed on the screen, and largely the white noise will be taken away. And that would mean that thousands of cameras would require a handful of operators, and these super agents are going to be helping the operators side by side, becoming better at their jobs. So with that, I will say thank you to everyone who joined this webinar. I hope it was as informational as we thought it was going to be. Thank you, Kev, for the wonderful explanation. And with that, I'll hand it over back to Ryan. Thank you, Ryan.
Thanks
very much, Mohammed, and thank you, Kevin. A really insightful presentation. So thank you both for talking us through that, and I've seen that we've had a couple of questions drop in. It's really interesting to see the evolution that that you've just spoken about, and it's clear that Icetana are spearheading this movement of self-learning security AI and autonomous security, and the examples that you were showing just then, Kevin, from around the supermarket and trying to detect dangerous situations that even the naked eye doesn't really pick up, really is phenomenal and gives us some real insights into how powerful this technology can be. A couple of questions from me first. Just as I've been listening in on the presentation, I wanted to flag a couple of these things. When we're talking about GPT products, what level of cognitive capability do you think these products currently possess and will possess in the future?
Oh, do you want me to take this more? Like
Go for it.
We so at the moment, like OpenAI's latest model cognitively is, the equivalent of someone who has a PhD. So it's not that, it wasn't that long ago that we had the same level of cognition as a cat. Like so well, available in AI, there was a real slowdown in AI, and then this sudden acceleration. But this to answer your question, Ryan, we use multimodal LLMs that could rewrite the works of Shakespeare in a particular style. So this is good, and because it's very clever. But what I think what will happen is that we will reduce the size of the models, and we will like so that we can get more compute. So I think in time we don't need the PhD to assess these events. We just need a core of security knowledge that can make the judgment calls. But the LLMs that are emerging just now are very, very clever, and these reasoning models are getting smarter and smarter still. So there's a lot of brain power out here. We just need to be efficient in how we apply it.
Sure. And Kevin, you mentioned that there was a slowdown in these and the development of these GPT platforms, and then a real uptake. What do you think has been the driving force behind that?
Well, so I'm talking about the AI winter from the 80s. So I'm giving away my age here, but in the 80s, and as a computer scientist, I was told come 2000 we would have a computer that would pass the Turing test, or it would be smarter than a human. And now the reason why we know that AI won't pass a Turing test is that it doesn't get any questions wrong, and that's not a human trait. So you can almost tell you're speaking to a computer because it's so clever. But the thing that accelerated it was transformers. This is the T part of GPT. The Google developed this technology. It sat on a bench somewhere, like actually sat for 3 years before they realized that it was a useful technology, and someone else picked it up and ran with it. But the transformer side of GPT meant that AI could have a longer memory, and so it was less like a goldfish. And now with technology and the GPUs, like the amount of compute that's available is massive for training these models. We're also experts in the GPUs. Like we roll out infrastructures that are probably equivalent to OpenAI in particular areas. So yeah, there's a lot of exciting technology that's unlocking these capabilities, Ryan.
Mm-hmm. And something that's made the headlines, I'd say globally recently, is DeepSeek. What are your thoughts on that? How do you think that's going to influence CCTV security?
Well, so DeepSeek is not a multimodal model. So DeepSeek is purely a large language model. It's a very powerful large language model. So in terms of the different agents that we've seen there, the agents that don't require to interpret images or videos, so things like a resourcing, things like phoning the police, these are the types of things that you would need this. Because DeepSeek is a strong reasoning model, so you would use that in the background to bolster the brains of the agent. But just to reiterate, we don't have a preference for a large language model. We can hot swap anything. Like we can use Metas, we can use DeepSeeks, and often it depends on whether customers are comfortable using OpenAI's data, or if you've got a dark site. A lot of our customers are dark sites. We would use OpenAI. We would use OpenTech to deploy GPT on a dark site. DeepSeek is interesting because of the whole distillation side of things. Like when you put that amount of knowledge out, there's a general understanding that DeepSeek distilled information from OpenAI, but OpenAI also distilled information from the entire internet. So I feel like this battle's going to we will be the winners of the battle between OpenAI and DeepSeek.
Thank you. And we've had a couple of questions drop in that are sort of more about Icetana and the products themselves. So I don't know if this would perhaps be your realm, Mohammed. But somebody's asking about facial recognition. Does Icetana embed facial recognition as part of its solution? And obviously, the recent AI Act in the EU that's prohibited the use of AI surveillance in some areas. How do you address that as well?
So happy to take that. And Kev, please add on whatever I miss. But instead of embedding, it's our own in-house code that we've generated. So it's our own facial recognition engine. And in terms of GDPR, we do not collect any PII data. So there is no personally identifying information that we collect, and therefore we are GDP compliant.
Fantastic.
We have it's worth mentioning because there are sensitivities around facial rec. Our safety and security product has no facial rec requirement. So our facial rec and our license plate recognition are separate modules, but they integrate well. But often, especially in Australia, there's a sensitivity to facial rec in Australia. So we build a product that has no facial rec, no LPR in it. But as Mo says, regardless of where we are in the world, we still know PII, so we're good with GDPR.
Thank you, Jensen. And what about infinity cameras as well? Do you think Icetana will ever reach the point where you'll be at infinity cameras?
Look, okay, this for me is infinity is a large number, right? So for me, it's it's an aspiration. We probably, to get to the point where, we're all sitting around dancing and writing poetry and AI is looking after everything. It's probably far off in the distance, but I think that we're definitely seeing order of magnitude increases. The 500 to 2,500, that's conservative. Like what I'm seeing in the lab is 5,000. So I think that there's a moment in time where the security, like you're still going to need humans to train the AI, to manage the AI, but you might not necessarily have humans sitting watching the cameras. So right now, like Icetana, we specialize in enabling the security teams to get ahead of the game, to become managers of AI. But yeah, it's going to be some way off. And even then, there will be a manager at the top that's managing the agents and effectively telling them what to do and training them.
Yeah. If anything, Ryan, it's going to add to the cognitive abilities of the operators in the room.
Yes.
For sure. And I think this is probably the last question that we've had come in. You both spoke about the triage agent quite extensively in that presentation. So if you could just elaborate a little bit more about this and its overall impact on the product, the solution, and security in general.
Look, I'm happy to take this. We have probably all up around 10 different algorithms in Icetana that monitor the cameras. So we'll monitor the speed of objects, the direction of objects, the location of objects, and then we've got these self-learning algorithms that adapt and roll. That will generally reduce like the video footage from like an hour to 30 seconds. So it will sift through the videos and it will only find and report on the things that are interesting. So that's roughly about half a percent of the overall footage that it reduces it to. When you add the triage agent, it takes that 0.5% and it reduces it by another factor of 10 to 0.005. And what that does is that it means that on the live wall, like as Mo showed at the end, there's a live wall. These events pop up, and you can watch it, but often just siphoning the events down to the interesting ones. This additional triage agent reduces it still. So this is where the 10x comes from. Instead of the cameras that you can monitor reduce down. So effectively the security team, they can watch it, but they can also go and have a tea break, or go and do more important things, or go and do more human things like be present, wander around, while the AI is automatically monitoring for escalation events.
Fantastic. Well, thank you very much for that, Kevin. It's been really interesting today, just to delve more into the evolution, the solution, and how Icetana is trying to constantly improve safety and security of people and places. So I thank you both a huge amount for that. I think in order to wrap it up, I'd like to hand over to each of you again for a quick sentence summary. So one sentence just summarizing the impact of this solution, and maybe what the future holds for Icetana. So Kevin, I'll go to you first, and then we'll finish with Mohammed.
Oh, so for me, for me personally, this means that I get to use my geeky powers for good. Like we've saved a few lives and over the years, and it's those moments where your AI is being applied, and like we've helped people stay safe. More AI, more acceleration means that we can do more good in the world. So I'm looking forward to that.
Thanks, Kevin. And Mohammed?
Well, I have been here at LEAP all this week, and all I can say is we're headed in the right direction. All I hear is AI agents and how it's going to definitely help the security in its pursuit for safety. So really excited and really, really happy that I'm going to be a part of it with Icetana.
Fantastic. Well, thanks to you both. And thank you to our audience at home as well for tuning in. We will have an on-demand version of this webinar available afterwards. And for everybody who tuned in live, you will receive a certificate of attendance from our team later this week. I would also encourage you to contact and find out more about Icetana by visiting their website or contacting Kevin and Mohammed directly. And I'll conduct a short follow-up with everybody so that you're able to contact them yourselves as well. And look out for Icetana at future trade events in the Middle East region. But I think that wraps everything up for today. So Mohammed, thank you very much from LEAP in Saudi Arabia. Kevin, thank you very much from Perth in Western Australia. And thanks to our audience at home. Have a great day.